Good evening, dear students. In the last lecture, we have discussed about the cyclic structure of glucose, right? Haworth representation. So this is the lecture number 4 in the biomolecule chapter. You can see the screen biomolecule lecture number 4. Today's date is 18/12/23 by Govind sir, and we are having our YouTube channel Chemistry Guru 1993. So what we have in the last lecture, we have discussed the cyclic structure, children. In that case, cyclic structure, if we are talking, so alpha D glucose and beta D glucose, two kind of structure we have discussed. Okay, Haworth structure, alpha D and beta D. So let's talk about the preparation method of alpha D and beta D. Alpha D and beta D are two crystalline form of glucose. What I am saying, alpha and beta are two crystalline form of glucose. Okay, alpha and beta are the two crystalline form of glucose. So let's talk about the preparation method, guys. C6H12O6, this is our glucose. Okay, in that case it is available in two kind, alpha glucose, beta glucose. Okay, so alpha glucose and beta glucose, in that case their melting point 419 Kelvin, and here the melting point is 423 Kelvin. If we are talking about preparation, so crystallization of concentrated solution of glucose, crystallization of concentrated solution of glucose at 303 Kelvin temperature, or you can say 30 degrees Celsius. Crystallization of concentrated solution of glucose at 303 Kelvin or 30 degrees Celsius, we will get alpha glucose. Here crystallization beta D glucose, crystallization of hot and saturated solution of glucose at 371 Kelvin, that is around 98 degrees Celsius. Okay, so these are the preparation method of alpha glucose and beta glucose. Tell me, children, one thing, which one is more stable in that case? So beta D glucose is more stable. Why more stable? Because it is having more melting point as compared to this 491 Kelvin and here 423 Kelvin. So it will melt at the higher temperature. So it is a stable more than alpha. So this is the thing. Okay, so check it once again. I'm telling you, alpha and beta are two crystalline form of glucose. This is your glucose, alpha glucose melting point, beta glucose crystallizes at concentrated solution of glucose at 303 Kelvin, hot and saturated solution of glucose at 371 Kelvin. So that is the process. In that case, what are the reason why state chain structure is fail? So that we can say failure of straight chain structure. Failure of straight chain structure, guys. Okay. So what are the reason? Straight chain structure fails to explain the following property. It fails to explain the following properties or reaction shown by glucose. What is written? It fails to explain the following properties or reactions shown by glucose, that straight chain structure. Okay, so check it. What are the properties? Number one, glucose does not show glucose that straight chain structure of glucose does not show 2,4 DNP test, 2,4 DNP test, SIF base test, and NaHSO3 addition product. See what is the thing written here: 2, 4 DNP test, SIF base test, NaHSO3 addition product. So that SIF base test already we discussed in aldehyde, that NaHSO3 addition also we have discussed. This is new for us, 2, 4 DNP. So 2, 4 DNP means 2, 4 dinitro 2, 4 dinitrophenyl hydrazine. 2, 4 dinitrophenyl hydrazine. What is the structure, children? Here NO2, here also NO2, here NH and NH2O test. It is your 2, 4 DNP. So what happened, children, with RCHO? It forms ROY. ROY means red orange yellow solution. So listen it very carefully. This oxygen, okay, and this H2 from here, water species remove, and it will form either red or yellow or orange color solution, which is not possible in the straight chain structure of glucose because that O not free in straight chain. Okay, that is the first reason. If we are talking the second reason, the pentaacetate, the pentaacetate of glucose does not react, with NH2OH to form oxime. In the evidence case, we form the oxime, if you remember, but here in that case it is not possible. That is why the pentaacetate of glucose does not react with NH2OH, form oxime. So these are the reasons, these are the two reasons, or you can say these are the failure of that straight chain structure, guys. Okay, failure of straight chain. Here orange color, yellow color, red color, solution not free. That's why it is not happening. That is it. In that case, so we already formed that alpha and beta structure, alpha glucose and beta glucose. So cyclic structure of glucose, what are the observation in that case? Cyclic structure. What are the observation? I am writing here the observation. Alpha and beta forms, are epimers of each other at carbon number 1, from carbon number 1. Alpha and beta forms are epimers or anomers of each other at carbon number 1. What is anomer? So what is anomer, guys? Anomer, anomers is a special type of epimer that differ in configuration, specifically specifically at the hemiacetal or acetal carbon atom. Okay, anomers is a special type of epimers that differ in configuration, specifically at the hemiacetal acetal carbon atom. So, in that case, you can say that alpha D glucose is also called alpha D glucopyranose. Glucopyranose and beta D glucopyranose. Okay, one note you have to write, it's important here. What is the note? Generally, hemiacetal or generally hemiacetal are unstable but in 5 or 6 membered ring they become extremely stable. Okay, one more line I am writing. Epimers and anomer are both distereomer. Distereomer. Distereomers. So once again, it's a theoretical portion. Listen it, children. Cyclic structure observation: alpha, beta are epimers of each other at carbon C1. Anomers are the special type of epimers that differs in configuration, specifically at hemiacetal acetal carbonate. Alpha D glucopyranose, beta D glucopyranose, generally hemiacetal are unstable, but in 5 or 6 member ring, they they become extremely stable. Epimers and anomers are both distereomer. Okay, so cyclic structure already we have decided. There will be no problem. Once again, I am telling you about the cyclic structure. In that case, 6 member ring, here oxygen, okay, below species down OH, H, OH, H, H, OH, OH, H, CH2OH, and here H. This is alpha D. It is also called alpha D positive glucopyranose. Similarly, OH, H, OH, H, H, OH, OH, H, CH2OH, and here H. This is your beta D positive glucopyranose. Okay, why pyranose we are using every time? So see, this kind of species in organic chemistry, it's called pyron. Okay, and O's means sugar, hence these structures are called pyranose. Pyranose. Pyron because of this species, and O's, that is sugar. And also they are glucose derivative. So so glucopyranose. So this is about the situation. Okay. In the same time, we are going to discuss the mutarotation. That is the very important topic, mutarotation. After the completion of mutarotation, we will wind up the lecture. What is mutarotation, children? See, try to understand in very simple language what is the work of glucose. Glucose is a optically active substance, right? That means in this solution, if we are having here ppl is coming, here ppl, plain polarized light, and in this container we are having alpha d glucose, alpha d glucose. So it is ability, these ppls are passing from this solution, then these ppl will be converted into they turned 112-degree angle. At the same time, if we are having another container, and in this container beta D glucose we are having, then what happened, and from here ppl is passing, then they turned 18 degree. Okay, and both are optically active. Already we know alpha and beta both are optically active carbohydrate. So this is how I know these 112 or 18. So these all information we are getting from experiment. These data we are getting from experiment. But in the one lecture, I told you alpha and beta forms are interconvertible. Alpha and beta forms are interconvertible. So if in the container we are having alpha D glucose, alpha D, so it's interconvertible, then it will be converted into beta D also. And from here we are passing ppl. Then what happened? Suppose 90% alpha d and 10% beta d we are having. So in that case, what is the deflection of ppl? What is the angle? So what you know that that alpha D glucose is able to rotate 112 degree and beta D glucose ppl rotate 18 degree, that we know. So more amount of alpha you are having. In that case, how to know the angle? According to the percentage, you can find out 90% into 112 plus 80 plus 10% into 18 upon 100. By this formula, you can calculate the angle. But the thing is, children, that alpha D converted into beta D till the equilibrium. Okay, and at the time of equilibrium the angle is 52.6 degree. How I know? That is also a experimental data. That is also a experimental data. So mutarotation, what is mutarotation? Mutarotation is that, so here angle is 52 point, this is the explanation. Okay, so mutarotation, the specific rotation of pure alpha D glucose or beta D glucose changes over time to reach an equilibrium value, and this phenomena is called mutarotation. So till the equilibrium condition getting, alpha D glucose is converted into beta D glucose and beta D glucose will be converted into alpha D glucose, and this conversion is called mutarotation, and after the equilibrium that mutarotation will stop. Okay, so this is the phenomena. I'm writing the definition, children, so be with me. The specific rotation of pure alpha D glucose or beta D glucose changes over time changes over time to reach an equilibrium value, and this phenomena is called mutarotation. This phenomena is called mutarotation. This phenomena is called mutarotation. Okay, so that exact value you can write here. It's a hypothetical data. The exact value is plus, because 112.2 degree, because dextrorotatory, and here it is plus 18.7 degrees Celsius. Plus 112.2 degree plus 18.7 degree, and after the equilibrium the angle is 52 point plus 52.6 clockwise only. Okay, so that is the definition. And after the equilibrium, mutarotation will stop. Okay, so that is the condition. After equilibrium, mutarotation stop. So I hope I explained well that mutarotation, and remaining from the fructose onwards in the next lecture we will cover. So thank you children, give your support. We are trying work to reach a good quality education to to for the society. That is why, if any correction you can tell me. All the best guys.